Relocating the meter base and disconnect prompts a design question regarding the feeder type. The National Electrical Code, or NEC, mandates a 4-wire feeder consisting of 3-phase conductors and a neutral conductor when the dwelling unit's total load surpasses 100 amps. To ascertain whether the dwelling unit exceeds this threshold, calculate the demand load. This calculation should factor in the building square footage and all applicable electrical loads. This load calculation is according to the NEC. The relocation of a meter base and disconnector pedestal located 120 feet from the building introduces potential voltage drop issues. Verify that the feeder size is sufficient to maintain adequate voltage levels at the main panel within the log cabin. Insufficient feeder size can lead to voltage drop, causing appliances to malfunction or operate inefficiently. To mitigate voltage drop, consider using larger conductors. Also, select the appropriate conduit type for the underground feeder. While PVC conduit might be suitable, consult with the utility company to confirm their specific requirements. Different utilities may have different preferences or requirements for conduit materials based on local conditions or practices. Coordination with the local utility company is essential to ensure the meter base and disconnect relocation complies with their standards and requirements. The utility company might have specific guidelines for the installation, grounding, and protection of the meter base and disconnect. The utility company might have specific guidelines for the installation, grounding, and protection of the meter base and disconnect. A thorough evaluation of demand load, distance to the structure, conduit type, and utility requirements is needed to make an informed decision regarding the feeder type. Firstly, calculating the demand load involves assessing the total electrical demand of the dwelling. This includes lighting, appliances, heating, cooling, and any other electrical equipment. The NEC provides guidelines for calculating demand loads based on square footage and the types of appliances installed. Secondly, the distance between the meter base and the main panel is a critical factor due to voltage drop. Voltage drop increases with distance, potentially affecting the performance of electrical equipment. The longer the feeder, the greater the resistance and the more significant the voltage drop. Thirdly, the type of conduit used for the underground feeder is significant for protection and compliance. The conduit should be suitable for underground use and meet the NEC requirements. It should also be resistant to corrosion and physical damage. Fourthly, coordination with the utility company is crucial to ensure that the relocation meets their standards. The utility company may have specific requirements for the type of equipment used, the installation methods, and the grounding system. To accurately assess the demand load, start by calculating the general lighting load. This is based on the square footage of the dwelling. The NEC provides specific guidelines for calculating lighting loads in residential buildings. Add the loads for all general-purpose receptacles. These are typically calculated based on the number of receptacles in the dwelling. Include the loads for all major appliances, such as refrigerators, ovens, washing machines, and dryers. These appliances have specific nameplate ratings that indicate their power consumption. Include the loads for any fixed appliances, such as water heaters, air conditioners, and electric heating systems. These appliances also have nameplate ratings that specify their power consumption. If there are any electric vehicle chargers, include their load in the demand calculation. EV chargers can add a significant load to the electrical system, so it is crucial to account for them. After summing up all the individual loads, apply the demand factors as specified in the NEC. Demand factors account for the fact that not all loads will be operating at the same time. These factors reduce the overall demand calculation to a more realistic value. Once you have calculated the total demand load, compare it to the 100 amp threshold. If the demand load exceeds 100 amps, a 4-wire feeder is required. If the demand load is less than 100 amps, a 3-wire feeder may be sufficient, but it's best to verify. Considering the distance between the meter base and the main panel, calculate the voltage drop. Voltage drop is the reduction in voltage that occurs as electricity travels through a conductor. It is caused by the resistance of the conductor and the current flowing through it. The greater the distance and the higher the current, the more significant the voltage drop. Use the following formula to calculate voltage drop. Voltage drop equals 2 asterisk length asterisk current asterisk resistance slash 1000, where length is the length of the conductor in feet, current is the current flowing through the conductor in amps, and resistance is the resistance of the conductor per 1000 feet. The resistance of the conductor depends on its size and material. Consult the NEC tables for the resistance values of different conductor sizes and materials. The NEC recommends that the voltage drop should not exceed 3% for feeders and 5% for branch circuits. If the calculated voltage drop exceeds these limits, you need to increase the size of the conductor to reduce their resistance. When selecting the conduit type for the underground feeder, consider the following factors. Firstly, the conduit must be suitable for direct burial. It should be made of a material that is resistant to corrosion and degradation when exposed to soil and moisture. Secondly, the conduit must be sized appropriately for the conductors it will carry. The NEC provides guidelines for conduit fill, which specifies the maximum number of conductors that can be installed in a particular size of conduit. Thirdly, the conduit must be installed at the proper depth. The NEC specifies the minimum burial depth for different types of conduit. PVC conduit is a common choice for underground feeders. It is lightweight, easy to install, and resistant to corrosion. However, it is important to use Schedule 40 or Schedule 80 PVC conduit for underground applications to ensure it can withstand the pressure and potential damage from soil and rocks. Rigid metal conduit RMC is another option for underground feeders. It is more expensive than PVC conduit but provides superior protection against physical damage. RMC is often used in areas where there is a risk of heavy traffic or other potential hazards. Intermediate metal conduit IMC is a lighter weight alternative to RMC. It provides good protection against physical damage but is less expensive than RMC. Before making a final decision on the feeder type, contact the local utility company to discuss their requirements. The utility company may have specific standards for the type of feeder, the grounding system, and the location of the meter base and disconnect. They may also require an inspection of the installation before they will connect the power. The utility company may require a single point ground. They may have rules about surge protection too. The electrical inspector should review the plans and specifications for the relocation to ensure they meet the requirements of the NEC and local codes. This review should include a thorough examination of the demand load calculations, the voltage drop calculations, the conduit type, and the grounding system. The electrical inspector should conduct on-site inspections to verify that the installation is being performed according to the approved plans and specifications. These inspections should include checks of the conductor sizes, the conduit installation, the grounding system, and the connections at the meter base and main panel. The electrical inspector should perform a final inspection after the installation is complete. This inspection should include a check of all the electrical connections and a test of the grounding system. The inspector should also verify that the equipment is properly labeled and that all safety requirements have been met. If the inspection reveals any discrepancies or violations, the electrical inspector should issue a notice of violation and require the contractor to make the necessary corrections. A final inspection should be scheduled after the corrections have been made to ensure that the installation complies with all applicable codes and standards. A detailed wiring diagram should be provided to the electrician to ensure that the wiring is done correctly. The wiring diagram should show the connections between the meter base, the disconnect, the main panel, and all other electrical equipment. The wiring diagram should also indicate the size and type of conductors to be used. A grounding electrode system should be installed to provide a path for fault current to return to the source. The grounding electrode system should consist of one or more grounding electrodes, such as ground rods, ground plates, or metal underground water pipes. The grounding electrode should be connected to the grounding bus in the main panel with the grounding electrode conductor. A bonding system should be installed to ensure that all metal parts of the electrical system are electrically connected together. This bonding system helps to minimize the risk of electric shock by providing a low impedance path for fault current to return to the source. The bonding system should include bonding jumpers that connect the metal enclosures of electrical equipment, metal conduits, and metal water pipes. Surge protection devices should be installed to protect sensitive electronic equipment from voltage surges. Surge protection devices can be installed at the meter base, the main panel, or at individual branch circuits. They divert excess voltage away from the equipment and protect it from damage. All electrical connections should be made with approved connectors and terminals. The connections should be clean and tight to ensure good electrical contact. Loose or corroded connections can cause overheating and electrical fires. All wiring should be properly supported and secured. The wiring should be protected from physical damage and should not be exposed to moisture or chemicals. Cable ties, clamps, and other approved support should be used to secure the wiring. All electrical equipment should be properly labeled. The label should indicate the voltage, amperage, and other important information about the equipment. The labels should be legible and durable. All electrical work should be performed by a qualified electrician who is familiar with the NEC and local codes. A permit should be obtained from the local building department before any electrical work is started. The work should be inspected by the electrical inspector to ensure that it complies with all applicable codes and standards. Also consider future expansion. Design the feeder system with enough capacity to accommodate future electrical needs. It is often more cost-effective to install a larger feeder initially than to upgrade it later. Proper planning and design are essential for a safe and reliable electrical system. By following the NEC and local codes and by working with qualified professionals, you can ensure that your electrical system meets your needs and protects your property. Consider consulting with a qualified electrical engineer to review the design and ensure that it meets all applicable requirements. An electrical engineer can provide expert advice and guidance in the selection of equipment, the sizing of conductors, and the design of the grounding system. The engineer can also perform detailed calculations to verify that the system will operate safely and reliably. It is important to document all aspects of the electrical installation. Keep records of the plans, specifications, permits, inspections, and test results. This documentation will be valuable for future maintenance, repairs, and upgrades. In conclusion, relocating the meter base and disconnector pedestal 120 feet from the log cabin requires careful consideration of several factors. The full wire feeder requirement, demand load calculation, voltage drop, conduit type, and utility coordination are all critical aspects that need to be addressed. Thorough planning, proper design, and adherence to the NEC and local codes are essential to ensure a safe and reliable electrical system.